Okay, so this is the review for your test. We're going to start by finding the zeros of the polynomials. We have multiple ways to do this. Okay, we may have to use the rational zero theorem and come up with all of the possible rational zeros and then test those using synthetic division. That is a possibility. We may have to go through quite a few to make that work. Or we could also try to factor it. So I suggest that if you can factor it, you try and factor it. If it doesn't factor, then we're going to have to do that. But factoring would be a whole lot easier most of the time than using the rational zero theorem. So when I look at this, if I can factor, I'd be factoring by grouping. So I'll group these two together. So right here, I can factor out an x squared. That leaves me with x minus 1. Out of these two, I can factor out a negative 25. Okay, so now to know if it's really going to work when you factor by grouping, what I'm left over with here, this would make this a positive x and then a negative 1. Remember that these two things have to match. If you try and do grouping and these don't match, then your grouping doesn't work, and then you have to go find other ways to handle it. So then this leaves me with x squared minus 25 times x minus 1. And then that's f of x. Okay? And then I can factor some more. This is a difference of squares, so this is x plus 5, x minus 5, and then x minus 1. So this is my factored form, so that's part of my answer. And then my zeros, this is going to give me plus or minus 5, and that's going to give me a positive 1. So here are the zeros and the factored form. All right, so now let's look at the next one. So the next one I have 5 terms. So factoring by grouping, not going to work for me. I don't know that, factoring isn't just anything I can do at this point. So instead, I need to use the rational zero theorem, which means I need to come up with all the possible zeros, which means that's going to be a ratio of the factors of the constant term. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. 5 doesn't work, but 3 times 4 is 12, so then there'll be 2 times 6, and then 1 times 12. Okay, all over the factors of the leading coefficient, so plus or minus 1, plus or minus 2. That means that my possibles here, I'm going to get plus or minus all of this over 1, so that's really just the list of the numerator. So plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, and 12. Then also all of the numerator over the 2. So that would mean I put 1 over 2, so that'll also give me plus or minus 1/2. 2 over 2 is 1, which I already have. 3 over 2, plus or minus 3/2. And 4 over 2 is 2, 6 over 2 is 3, 12 over 2 is 6. All those are already taken care of. So those are my possibilities. So I will start with 1. So 1, and then make sure that you leave zeros in here if you need to. So this is x to the 4th, that's a 2, and negative 1, negative 11, 4, and 12. All right, so bring down my 2. X is 2, 1, 1, negative 10, negative 10, negative 6, negative 6, positive 6. So I did not get a 0 there, which means this does not work. So now I move on to negative 1, 2, negative 1, negative 11, 4, and 12. Bring down my 2, so this is going to give me negative 2, negative 3, 12, negative 12, and 0. Okay, so I get a 0 here. This 0 right here tells me that this does work, so it is one of my factors. That means I have f of x is equal to, use that, x plus 1 times what I have left here. So that was x to the 4th. That means this is going to be a 2x cubed. 2x cubed minus 3x squared minus 8x plus 12. All right, so then at this point, I need to factor this some more, or if it doesn't factor, I'm going to have to go back to the rational zero theorem. So I'm going to try and see if I can factor it by grouping. If I can't, then I'm going to use this reduced form here and then keep going down the line of my possibles. So this x plus 1, we don't want to lose him, right? I'm going to try and factor by grouping, which means I'm going to add some brackets in here. Out of these two, I can factor out an x squared. That leaves me with 2x minus 3. Out of these two, I can factor out a negative 4, which will leave me with 2x minus 3. So that's good news because these match, which means I can actually use that. So then I have x plus 1 times x squared minus 4 times 2x minus 3. Oops, I lost my 1 in there. Then I can factor this some more because it's a difference of squares. So x plus 1 times x plus 2 times x minus 2 times 2x minus 3. So this is my factored form. Then I can get my zeros, which is going to give me negative 1. Then these two give me plus or minus 2. Then that's going to give me a positive 3/2. There are my zeros. Okay. All right, so here we are going to use the remainder theorem to evaluate. When you are going to evaluate a function at something, then this is the number that goes outside. You don't change the sign on that. So inside my synthetic division, which this is really synthetic substitution, this is going to be 1. There is no x cubed term, so there needs to be a 0. Do not forget to pay attention to that. Then negative 5, negative 17, and 15. Okay, so this will be 1, 2 here, 4, negative 2, negative 19, negative 38, then that 15 is going to give me negative 23. So then you have to understand what this is telling you, okay? We have this function, this is some x value, and so we've just evaluated it at that value, which means f of 2 is equal to negative 23. All right. Next page says, use the factor theorem to determine which binomials are factors. So now I want to figure out whether or not these over here are actually factors of this polynomial. So I'm going to start with the x plus 6, which means it's negative 6 that goes on the outside. Then I'm going to have 3, 13, negative 32, and negative 12. Bring down my 3, negative 18, negative 5, 30, negative 2, positive 12, which gives me 0. So that tells me then, since I got 0, that x plus 6 is a yes. So that one's a yes. Then I'm going to move on to x minus 2, which means 2 goes on the outside. And since this is a factor that worked, then I'm going to use my reduced function here, my reduced polynomial, so I can have 3, negative 5, and negative 2. Because if that's also a factor, then that means it would have to be multiplied by x plus 6 at some point, so I've already taken that part out. Bring down my 3. This is going to give me 6, 1, 2, and 0. That works. That means that x minus 2 is also a yes. So now when I move on to do x plus 4, that means a negative 4 goes on the outside. I can use my function that's reduced once again. So this is 3 and 1. Bring down my 3. So it's 3 here. 3 times a negative 4 is a negative 12, so this would be a negative 11. So that would be x plus 4 would be no. Okay. All right, so then we're going to use the rational zero theorem to list all the possible rational zeros. We really already did this on the front because that's something you have to do within another problem. But remember that it is a ratio of the factors of the constant term, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, over the factors of the leading coefficient. So that means that your possible ones part of the list is always going to be just the factors of this, because it's all that over 1. So I got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And then I have to do all of these over 2. So 1 over 2 would add in plus or minus 1/2. 2 over 2 is 1. I already have that. 3 over 2 would be plus or minus 3/2. Then 4 over 2 is 2. I already have that. 6 over 2 is 3. I already have that. 12 over 2 is 6. I already have that. So this is my list of possible rational zeros. Okay, so now we're going to use Descartes' rule of signs to give the possible number of positive and negative real zeros. So I have f of x. I'm also going to need f of negative x. Remember, that is very easy to find. All you have to do is change the sign on every term that has an odd exponent. So it'll be negative 3x to the 5th plus 6x to the 4th plus 14x cubed minus 28x squared minus 15x plus 40. You never change the sign on the constant term because it is constant. All right, so then I'm going to look for my possible positives and negatives. Remember, this is very simple to do. You are just looking at the variation in sign. So this starts off positive, stays positive, changes to negative. That's one change. Stays negative, changes to positive. That's another change. Stays positive. So that means there are two variations, and then it always goes down by an even number. So it's 2 or 0. If it had been 4, it would be 4, 2, or 0. If it had been 6, it would be 6, 4, 2, or 0. Okay. Then I look at f of negative x. So it starts off negative, changes to positive. That's one change. Stays positive, changes back to negative, stays negative, changes back to positive. So there's 1, 2, 3 variations, and it's 3 or 1, because again you go down by 2's. So it's 3 or 1. If it was 5, it would be 5, 3, or 1. If it was 7, it would be 7, 5, 3, or 1. If it's just 1, it's 1, because you're not going to end up with negatives. Okay, and it's as easy as that. Here is the answer. All right, so now we're going to use the given zeros to write the polynomial function. So I have this negative 4/3, which means I start off with 3x plus 4. Then I have this negative 1, so that is x plus 1. Multiplicity is 2, so it's squared. I'm going to rewrite this 3x plus 4. Remember, this is a perfect square trinomial, so you can FOIL it out if you want to. But what happens is you square the first one, x squared. You multiply these two together, which just gives you x, and double it. And then you square the last one, which is 1. Then you got to multiply all this out. So I'm going to take this 3x and distribute it over here. So I get 3x cubed plus 6x squared plus 3x. Then I take that 4 and distribute it. So plus 4x squared plus 8x plus 4. Then I combine all my like terms. I only have one x cubed term, so 3x cubed. I have 6x squared and 4x squared, which is going to give me positive 10x squared. I have 3x and 8x, which gives me a positive 11x, and then plus 4. And this is my polynomial. All right. And if you did Descartes' rule of signs on this, check this out. You've got 0 variations here, right? Which means 0 positive rational zeros, and then look, bam, or 0 positive real zeros, and look, you don't have any. It's negative and 2 more negatives. All right, so then I'm going to solve the polynomial inequality. So it's already factored for me. That was nice. So I have this. I need to find my zeros. It's going to give me -5, -3, and 4. And I draw my number line. Got to plot all these on here. I have -5, -3, and 4. Then this is just less than 0, so they're all open. Then I'm going to pick test numbers. I'll start with numbers -6. And so I substitute in here. This would give me a negative, -6, and there's negative, negative. So altogether, that's negative. If I use negative 4, I'd have negative, negative, positive, which is positive overall. Between negative 3 and 4, I can choose 0, so it's going to be positive, negative, positive. And then 5 is going to give me positive, positive, positive. So this is what I have here. So I want it to be less than 0. That means that it needs to be negative, so I shade my negatives. Remember, your number line is part of your answer. So your shaded number line, and then you have to write it in interval notation. So I'm going from negative infinity to negative 5. Never include my infinities, not including negative 5 because it's an open circle. Then I go from negative 3 to 4. Those are both open circles, so those are parentheses as well. And there you go. All right, so then I have a rational inequality to solve. In order to do this, I'm going to need to factor the denominator. So this leaves me with x plus 3 over, and then I'm going to get two binomials, x and x, because this is 1. This is negative, which means my signs are opposite. And that would be a positive 8 and a negative 1. That's supposed to be less than or equal to 0. So then my zeros I get from the numerator. My vertical asymptotes, because it's a rational, I get from the denominator. I'm going to have x equals negative 8 and x equals 1. So I'm going to draw my number line. I have to plot all of those on there. So I have negative 8 over here. And then there's a negative 3. And then 1. Then I got to look at my circles here, whether they're opened or closed. And this negative 8 is an asymptote. Asymptote are always open circles. The negative 3 is an x, and this is less than or equal to, so this is a closed circle. This is an asymptote, so it's open circles. So remember, you can have both things going on here. So I'm going to start with a number. Let's use like negative 9. So negative 9 in the numerator gives me negative. Negative 9 here and here is negative and negative. Overall, that's negative. Substitute in a negative 4. It's going to give me negative, positive, negative. So overall, that's positive. Between negative 3 and 0, between negative 3 and 1, I can substitute in a 0. So this is going to be positive, positive, negative. And then if I substitute in 2, I'm going to get positive, positive, positive. I want this to be less than or equal to 0, so again, it's my negatives, so I'm shading those. Then I'm going from negative infinity to negative 8. Never include my infinities. This is an open circle. And then I'm going from negative 3 to 1. This is a closed circle here, so that's a bracket. Open circle here, parentheses. There are my intervals. Okay. Make sure that you understand how to do each piece of this review and why I did what I did. Make sure that you look back through your ISN, and I'm grading them, so make sure they're put together as well. And make sure you look back over your returned homeworks so that you can make sure that you're hopefully not doing making the same mistakes if you made any the first time around. Okay? Be ready for this test. You'll be able to do fine.